Good morning, everyone. In the last session, we discussed about the another important section called linked list here. We'll try to identify the linked list example, how it is going to work internally. So observe carefully what we did earlier. Like we identify the one of the important class called linked list. So I'm trying to open this class. Now you can see this particular class we are going to discuss here, how it is implementing internally. Okay, we'll try to focus with help of this particular constructors here. Now this class we created for this particular array list here. Now I'm going to create one more class. So this particular class will include the linked list. Linked list demo. And inside this particular linked list demo, now what I'm doing here, I'm trying to create from the constructor onwards. So how this particular constructor and all those things it's going to create it, we'll identify here. So now same whatever we discussed the particular linked list string, the element I'm going to use the same string here, and after using this particular string, now I'm going to use ll. So it is nothing but linked list here, and linked list. Now, if you observe how many constructors we are having, only two constructors. First one, if you observe carefully, default constructor, and second one, which is expecting collection here. Okay, so there is no capacity here. Getting Ben. So whatever the capacity we identified inside this particular array list, right now we don't have any capacity. Now I'm trying to call the default constructor because we already identify the collection related section, how it is going to work internally. Okay, now so another important here, what we need to understand here, how this particular without the capacity, how the linked list is going to create internally. So that we need to understand very carefully. If I'm going to show you, this particular linked list, nothing is there inside this particular default constructor. We don't have much information. Okay, we don't have much information here. Now what I will do here, so whenever we are calling this particular default constructor, we are not doing anything. So because of this, I'm going to call add method. Now if you can see add method, what are the different add method we are having. So add method is the first one is coming from the collection interface, and second one is coming from the list interface, and now you can say add first, add last. Getting the point. So here we are able to see add first method as well as add last method. So these methods are coming from the DQ interface. DQ interface internally, which is extended from the Q interface. Okay. So this is very important here. First, I'm going to add this particular the default add method, which is coming from the collection interface. And here I'm going to add same elements like whatever we added yesterday. Whatever we added yesterday, I'm going to add the same element here. Okay. Now I call this particular add method. Now what I will do here, I'm going to provide the breakpoint so that we can identify how this add method will working internally. Okay, how this particular add method is working internally, we need to understand. Now you can see I'm calling this particular add method. I'm moving inside this particular add method. What do we understand internally? Link last. Getting the point. Link last method it is calling. So whenever it is calling the link last, now we'll understand how it is implemented internally. Okay. So what is the last node right now? What is the last node we are getting? Null. Getting the point. So how many nodes by default it is defined here? Two nodes. Okay. Two nodes are defined. First one is like first node and last node. Where we identify this? Yes.
So it's showing the last one is null. So is it the yesterday you showed that node? Is it that one?
Yes. Here only I'm discussing that. So these
No,
two
no.
nodes.
Yes, yes. You showed that that hierarchy.
Yes, correct. The node hierarchy, what we discussed in the last session is same.
So their first and last is null.
Yeah, right
Where
now
we
it is
put.
the first record we are inserting, right? So because of that, the first and last everything will be null.
No, I'm just checking. Am I right? My understanding.
Yes, it's correct. What you like what you are trying to think. Okay, now you can see what we need to understand here. Here we are having default to two nodes are declared here. Like it's like a variables. Okay, how we define the class level variable? Here they define the two variables. So the return type of this particular two variable node here. Okay, now here you can see first and last node. So how we define the in the previous example something like private into something like a count. How we define the same variable, but instead of this particular int, they are trying to return the one more node objective. So and node also internally it is the type called generic. So that node we are going to pass as a element here. Okay, so this is we are doing, and we are having two variables first and last. In the current example, what we are doing here now, if I'm going to show you, now you can see we are trying to call the we are trying to load the last node. Okay, whenever we are calling this particular add method, every time it will try to insert the record on the last node. Getting the point? So right now, this is the first record, the last node will be null. So same way, the first node also will be null. Same way, the first node also be null. Okay, now you can see if the last node is null, what we are doing, we are trying to create a new node. So why I'm creating this particular new node? Getting the point. We are trying to inserting one record. The record it is going to create inside this particular node. Okay. Now you can see what is the L basically here. Now if you observe carefully, what is the L? It is a last node reference. Okay. It is a last node reference. And what is the E? E is a element type. So as I explained earlier, now if you observe carefully, this is the last previous node references item and next node. So here previous node information what we are doing is we are trying to copy the last node information item. So item will be AB. So how I'm trying to store this AB? Because here you can see the second parameter we are passing as a E. And so last node every time as I explained it will be null. Okay, because of this last node, the next there is no next references. Whatever this particular previous reference is, we are making the last reference, like it's like a last node reference. But here, because of this particular first record, this node also will be null. So as I explained here, first record previous node is null, and for the last record, the last next reference is null. Getting the point? This is important. So if I'm going to add few more records, like if I'm going to add three records here, what happens internally? This references will be this particular previous year, and this particular references will be this particular previous, and here finally we'll have a null. But if we observe, every time whenever we are trying to create this particular node, the last next references we are making as a null, but after making this particular null, the new record, if you see the previous we are making the with the last references here. Previous record we are making the last references. So carefully observe, because of this particular first record, now you can see this is a null because last node we are making, the last node right now we don't have, so that it will be stored as a null. And here I'm trying to make as a AB, and right now this is also we are making null. Okay, so this is important. This is the first node we are trying to create. Okay, after creating this, now you can see what we are doing here. What we are doing here, here we are trying to make whatever the new node we created, now I'm trying to make as a last node. Getting the point? Now I'm trying to make as a last node. Right now, new node and last node will contain the same information. Now you can see if I'm going to expand this, item is available. So next reference is null, previous reference is null. So same we are making in the diagram. Okay. After making this, if L is null, they are making as a first. Okay. But right now, what we are doing is, so this particular L, it is null here. Okay, this particular L is still null. You can see in the right side variable section, the L is null here. Whenever this particular L is null, we are making as a first node. Okay, now what you understand here? first node as well as last node, everything is same. Getting the point? First node and last node, everything is same. This is important, we need to understand here. Getting the point? Now you can see first node. Now if you observe carefully, first node also, what happened? Let me load the references. First node also will contain the AV, next reference and previous reference is null. And same way, the last node also will contain the same. Okay. Now you can see the size I'm increasing. Right now, what is the size we are having? By default, it is 0. We are increased to 1. And the mark count basically how many methods we are called internally. So this section it is providing the information. Okay, using this particular size method, we are increasing the size. So now we understand the how this particular linked list working internally. Okay, how linked list is working internally. So there is no the concept to call array object array related section. Getting the point? Only the array list internally it is fine to use on the particular arrays concepts. But what about this particular linked list? It is fine to use on the node data structure basically. Okay. Now observe carefully after printing this. Now I'm going to add ll dot one more add method. Now if I'm going to add this, how this one it is going to work. So this is important. I'm going to store in the one index. Okay. I'm trying to store in the one index and I'm going to provide as a CD. Getting the point? I'm trying to provide as a CD. Now observe carefully how this example it is going to work. Again, I'm trying to run in the same debug mode here. Okay, so we discussed this particular AD. Now I'm trying to discuss because this method is a specific method which is coming from the which interface? List interface. Here we are trying to providing index information. Okay, here we are trying to providing the particular index information. Okay, this is very important section we need to understand here. Now I'm trying to move inside this particular add method. So observe carefully. So this we have discussed yesterday also. Whenever we are trying to provide, we are trying to check this particular position index, like range index. The method name is different, but the purpose internally it is same. Now you can see is position index. What we are doing is index greater than or equals to 0 or whatever the index we are providing, if it is less than or equals to size. So whatever we provided here, whatever we provided, it is a size is matching. So right now, what is the size? 1. Okay, 1. And whatever the index I'm providing, 1. Getting the point? Whatever the index I'm providing, 1. Because of this, it is matching here. Now, what you understand here? So we cannot provide this, the say size and the index information. Now, if we observe carefully, if I'm trying to check this, like if I'm trying to inspect this method using Control Shift I, using this particular Control Shift I, any exception we are getting? So right now we are not getting any exception. Okay, this is the way of checking this particular index information. So what is the index we provided here? Now the index we provide as a 1. Now what happening internally? Index equals to size. Index equals to size. So it is matching here. Getting the point? It is matching here. So observe carefully because whatever the index we are providing 1 and whatever the size we are providing, the size also matching here. Okay. Now again we are going to call this particular link last method. Whenever we are calling this particular link last, now what we need to understand basically. So again we need to check on this. So what is the last node we are trying to load? So this is the same record because in the first node as well as in the last node, because of this particular first record, we inserted in the two locations, first location as well as last location. So this is the value we are having. So now I'm trying to load. Now I'm trying to create a next node. So here, every time we are trying to create a new node with help of this particular last reference and e value. Now what you understanding here? So here I'm trying to create a one more node here. Okay, and this node is containing this particular CD value, and what is the reference we are making? This reference we are making as a last node. So this is only our last node as of now. Okay, this is only the last node information. So here we are making the last node. Now observe carefully when we are going to make this particular relation. Now if you see carefully how we are trying to executing this. So new node I'm making as a last. So right now, which node is the last? Once this particular 147, the line number will execute, this node will become the last node. So earlier, this is the node. This is the node is in the last status, but right now we are trying to make this particular node in the last status. Okay. So observe carefully. Right now, this is the last node we identified here. If I'm going to open this, AB and next and previous is null. Same way, the last node, now if you see, CD, next is null, but previous we are having the reference. Okay, previous we are having the reference. How we are making this reference here? Now you can see item. Getting the point? This is important here. Okay, this particular linked list, like whatever the item we store, this item is having the previous relation, but this particular AB right now cannot have the next references. This is very important here. Whenever we are making the relation, these two nodes, it should contain the two references. This particular last, it's contain the previous information, and this particular node, it contain the next reference, but still this next reference is showing as a null, but only this particular previous reference is making as a this particular object information. Okay, how we are making this particular the null next to null references as well? So observe carefully, this is important here. Now, so now L is null? No, L is not a null. Getting the point? Because we are having some last node informations here. Now, if you see here, by using this section, now what you understanding here I'm making the next references. Okay, here I'm providing the next references. Okay, using this particular new node, we are providing the previous reference. So once this example is completed, now we'll understand how it is working internally. So if I'm going to show you the last node, if I'm going to show you this particular last node, the last node can contain the previous reference, and internally, whatever the previous node we created, it contains the next references. Okay, it is contain the next references. There is no previous because it is a first node. First node cannot have the previous reference. So these previous references every time it is null. But here we are having the next node references. So you can see now directly we are trying to connect with this previous node of this particular CD. Okay, this is very important section we need to understand. Any questions on this? Whatever the two nodes we discussed so far?
So this line number 151, so is it showing the L dot next? So
Yes.
the second number last, this one, the second in the second stand index last.
See, if we observe carefully, first, what is the last node? Earlier we are having, we are trying to load here. And whatever the last record we loaded, we set into this particular L. Okay. This is important we need to understand here. So observe carefully. Earlier we have only one record. This is the record we created, and this record I stored in the last as well as first also. Okay. So this. Getting the point. In the two records, we are having same value. Now, whenever we are having same value, now what I'm doing here, I'm trying to load the last. So when we are trying to load, so this is the record is going to load. Okay, this record initially it is contained like this. Initially it is contained only AB value. So here there is no references, and this we made as a null. Okay. Now what I'm doing is the L containing this. Right now the L containing this. Now I'm trying to creating one more node. Now you can see this is the one more node I'm creating, and here I'm making the L here. Whenever I'm making the L, what happens internally? Here, so we are trying to load the previous references here. Here I'm making one references that is contain the L object. And what is the value I'm providing? CD. So right now this value null, because here we are providing the null. Okay, so two two nodes are we are having right now. One is newly created, one we load from the last node. And now you can see what I'm doing here. Now what I'm doing here, I'm trying to overriding here. So whatever the last earlier we are having, okay, the last I try to stored into this particular variable called L. Now this particular last is now modifying with a new node. So become, which is the last node now? This is the last node. Okay, this is the last node. But this still, this particular node, the current node, first node, it is available under this particular L. Okay, it is available under this particular L here. Now, what we need to understand here, if L is null, no. L is containing some object information here. Here we can see this particular L, it is containing this particular information here. So once it is identified, now what I'm doing here, so this section will not return true. So this condition will false. Now we are moving into the 151 line number. Whenever we are moving this line number 151, what I'm doing here, L dot next, L dot next. So if I'm going to show you L basically, here you can see node it is, now next node and the previous node. But how we are identifying? Here we are trying to make one more object reference. There is no, like if you see, this is the element type item, and now if you observe carefully here, we are having, so object references these are. So these are not the primitive type. Getting the point? So whenever we are having this particular object type here, now what we are doing here, we are trying to initializing whatever the new node we created, the new node I'm trying to set into this particular next here. Whenever I'm trying to set like this, here, this, the new node references is going to set here. Okay, so as of now, this is the null value we have, but now it is reflected with the references, so which is containing this particular node information. So this is the line number is showing here, because the right side value we are trying to set into the left side here, but right side basically it will set only references here, because here internally it is an object type. It is not any primitive or string type here. Okay, is it clear?
Yes, sir. So, sir, this one is clear. So, if we have one more node, so then the new one, the new node again, it will contain in the second one, last node. The
Observe.
third one, the
Wait.
value, it will come
So
in the
right
second.
now, how many nodes we are having? Two nodes.
We have two.
Two, right? So the previous we are having null, and the value we inserted as a AB, and next node. This next node, this previous node. Just now we made the references here. Okay. Whenever we are making this particular references, now what we need to understand here? Now what we need to understand basically, these are all the references we provided here and CD. Now what we can understand, the last is modified, so this we can call it as a first node. Okay, and as of now this is the last node, because here we are having null values, and here we don't have a null value. Here we are having next references, next node of this particular CD, and here we are having previous node of this particular AB. Okay, so here we are having bidirectional operations here. Like you can see, from the AB we can call the CD, and CD we can load the particular AB. Okay, here we are having bidirections information. So once we provided, as of now, this is the first node and this is the last node. So I'm trying to inserting one more node, something like EF. Okay, whenever I'm trying to inserting one node, first what we are doing here, line number like 145. So here we are trying to load the last node. So which node it is going to load? So the last node we are going to load as a this.
This
Okay, this node is going to load. Now this node, now it will store into this particular L variable. Whenever it is stored, now what I'm doing here, I'm trying to create a one more node. So here I'm trying to create a one more node. Okay, and here again we are having the same references variable like a previous node and next node. As of now, here I'm trying to store L. So what is the L? L is containing this particular node. Okay, here I stored this particular L. So here I'm making the references. So something like a previous, something like a previous node. So because this L and it is containing this particular last information. Now I'm trying to making the references here. So because of this L, okay, the first parameter. And the last parameter, what we are doing here, we are making null. Getting the point? This is important here. Now if we observe, whatever this last node we are having, the last node information, now I'm making into newly created node. Newly created node here. Okay, because of this particular L, whatever the L we are passing here. So the L we are trying to set into the constructor. If you observe carefully, I am trying to explain in this constructor internal. Now you can see this is the previous node, and this is the element, and this is the next node. Getting the point? Here we are trying to set into the previous. Okay, the L, whatever the L we are passing here, this particular L, now it is setting into the previous. So here we are having the previous link here. Getting the point? Whatever we are having here, the previous node link we are adding here. And after this, here as of now, for this particular last node, we don't have a the next node link. As of now, we did not make any link. Only we made one direction operation. So there is no as of now bi-directions here. Only this particular directions we made. So something like new node we created. For this particular node, I'm trying to make as a previous link. Okay. So is it clear up to the line number 146? Any questions?
No, sir.
Anyone
Clear.
having any? It's clear, right? So once this new node is created, this new node, now it is trying to. So this is comes under the new node. Okay. So this is the new node, and as of now we are having last here. Now after this, now what I'm doing here, whatever the new node we created, now I'm trying to set into the last. So this last as of now no longer available. Whatever the new node we created, now this particular new node, it has become the last node because of line number 147. Okay. Now the last node is modified here. The particular last node is modified with help of whatever the new node we created here. Okay, so this is important. After creating this, now I'm checking line number 148 if L is null. So this particular L is not null here because this L is containing this particular information here. So whenever this particular L is containing this particular information, so we are not going to match this particular record here. Only first time this record will match, and every time we'll move on to this particular line number 151. Now you can see what I'm doing here. I'm making the L dot next. What is the L containing? L containing this. L containing CD related object. Whenever this particular L it is containing L containing this particular CD related information. Now what you need to understand here? What you need to understand? The next we are making the references here. So whatever the next, as of now this particular next is null, and using line number 151 we are making the next. So what is the value we are trying to store? The new node. So here we created the new node. So this particular new node we are making the references to this particular next here. Okay, so this is the way. Now finally we are making the bi-directions here. This is where we are going to make the bi-directions operations here.
Got it, sir.
Okay. Anyone having any questions regarding this nodes concept? Okay. So now you can see, now what I'm doing here, I'm increasing the size. It is still we are inserting the second record. Now, once we inserted here, now I'm trying to come back to here. Now what you understand here internally, so this section is going to store as a linked list here. Now, if I'm going to print this, how it is going to print here? Now we need to understand here. Only values it's printing. Okay, whatever the values so far we are having, the values it's printing AB and CD. Whatever the node concept here. So for this, first what we need to understand, we need to check on the two string here. where we implemented this particular toString. So far, the toString is not implemented inside this particular linked list. Okay, if it is not implemented here, now which is the class we need to check here? Something like abstract collection. We need to identify the abstract collection, and I'm going to, sorry, not this. I'm going to put a breakpoint on this particular toString. Whenever I'm trying to put a breakpoint on this particular toString here, now what we need to understand here, so carefully observe, we'll try to run the same example one more time. Now I'm trying to run this example one more time, and the toString is calling. Now you can see toString method we are calling here, and which is coming under this particular abstract collection. So using this particular iterator, now we discussed in the last example, it will try to perform only the forward directions here. Okay, and what is the IT we are having here? And here you can see the IT sections here. Now you can see next we are having. So what is the next node we are going to get? Something like AB. So something like we are going to get, because this is the next method. Internally it is containing the linked list node concept, and the first record we are trying to load, and it is having next node references here, and internally the next node will contain the CD, and so this is the previous information, but you can see next node is null. Okay, next node is null. So we'll identify again itr.next. So here we are making false. Whenever we are making the false, it will return empty. But right now we are having some records here. We are trying to creating string builder object here. We are trying to appending with this. Okay, we are trying to appending this. Now, what you need to understand here, because here we are calling it.next. it.next. Whenever I'm trying to call this particular it.next, what happening internally? We'll get this particular linked list here. Now you can see what is the E contained here? AB. Okay, what is the next it is trying to returning here? It is trying to returning this particular AB. But this node, where it is implemented here, where this particular iterator is implemented, so this section we need to understand. Now I'm going to open this. Okay, iterator is not yet implemented, I hope. Okay, so there is no iterator concept here, and if it is not there, I think here also we did not implemented this. It is a abstract method. Okay, now so what I need to show you, abstract. Where is I will go to the linked list. Now I will move on to the abstract sequential list. Here we need to identify any iterator. Yes, here we are having iterator. Now internally it is calling list iterator. Internally it is calling list iterator. What we are doing here, we are trying to call the okay, abstract it is calling. So finally next, now you can see whenever we are calling this particular next, this is the section it is implementing. Okay, now if you see carefully where we are calling inside this particular abstract collection, we'll go to the toString. Now you can see here I'm calling it.next. So whenever I'm calling this particular it.next here, this particular next method is calling. Okay, this particular next method it is going to call. Now you can see we are trying to load this particular next, and we are trying to implementing cursor and lost RET value something, and we are returning this particular next here. Okay, so this is important here. Now I'm going back to this particular next, and we are having element. If the element is null, we'll try to add as a this collection. Otherwise, we'll add as a E. Okay, so far we are going to add this particular E. Now if you see this particular append here, so it's open one array bracket here, and AB values appended. And after this, what happening internally? We are trying to move on to the append here. So one append is going to add as a comma, and another one append is going to give as a some space here. So now you can see. Now if you see what happened. So here I will open the variable section. Now you can see. So array bracket is open, AB and comma. After comma, you can see some space we are having. Some space we are having. This much is the space. Right. And after this, because of this particular infinity loop, now what we are doing is we are trying to repeat one more time. Now what is the value we are getting right now? CD. Okay. The next node, the E, here we are getting CD. So this particular CD, now it will try to store into the this particular append here. Now if you see this particular AB, observe carefully. Here we are having some space, okay, comma with the space, and it is available. If this particular ITR does not have the as next element here, now it is trying to use the close bracket, and we are calling the to string. Okay, this is important here. This is important. Now finally you can see the last in the console we are able to see AB comma CD. Okay, because of the toString method only we are getting this particular information. Now what we can do, if you are not interested this particular toString, we can override the toString information and we can call the specific toString method. Okay, this is we need to understand very carefully how this particular toString is going to work. So far we are having two nodes. And now what I will do, another method I'm calling, because right now we discuss about the add method, and the second one also we discuss here. Now add all we'll discuss later. Now add first, add last. Okay, these are all the two.
Which should be.
Okay, these are all the two important method we need to understand how this particular add first as well as add last is going to work. First I will call this particular add first. So whenever I'm calling this particular add first, I will try to provide as a YZ. Okay, I'm trying to providing this particular Y and Z as a first element. So if everything is so goes successfully, what is the value we are expecting here? The value we are expecting like this, like Y, Z, and AB and CD. Okay, this is the output we are expecting. Now we'll see how this particular output is going to print this. Now you can see whatever the output we are expecting here, the same output we are getting here. So because of this particular add first, now what happens internally? Getting the point. What happens internally? Already the first record, the first node we created as a AB. Now this AB you move on to the second node. So because of this particular YZ we created as a first node. Getting the point. This is important here. Now we need to understand how it is going to work internally. Now if I'm going to debug this particular code in the debug mode, now we'll understand how it is going to run internally. Now I'm trying to call, because we already inserted two records. AB is the first record, CD is the last record. So it's clear. Now I'm trying to inserting one more record as a first record. The Y and Z I'm trying to insert as a first record. Let me move on to inside this particular method. Now you can see which method we are calling, link first method. But whenever we are calling the add method, which method we are going to call every time? Link last method. Okay, link last method. So this is important here. Now you can see I'm calling the link first method internally. Whenever I'm calling this particular link first, what we are doing here? What we are doing here, now you can see here, this is important. First node. So what is the first node we are having? First node basically AB. Okay, whatever the AB we are having, let me clear this. Here you can see, so this is the first node we are having, AB. Okay, so this we discuss as a AB. Whenever, if how we can identify this is the first node or the last node, the first node will contain the previous node is null, and the last node can contain the next node is null. Okay, you can see the previous is null, and if I'm going to expand the next one, the next node is null. The previous node is we are having an object. So that CD is the last node, because the next node it does not have any information. Okay, this is the way we can easily understand the first node and last node. So first node we created, like we load as a AB record, and observe we are trying to create a new node, and here the previous node I'm making null. Okay, the previous node I'm making null element value, and whatever the next references we are having, the references I'm making as a F. I'm making as a F. So here I'm going to create this particular node as a F, and this particular node as a new node. Okay, so this I'm going to give as a new node, and here I'm trying to give as a F here. Whenever I'm trying to give as a F, what is the values we are having earlier? So this is the AB we are having, and next reference. Okay, next references I'm not add like I'm adding the next references here, and right now what is the node we created here? This is we are making as a null here. Okay, and here we are making something like what is the value? Y and Z we are trying to store. And after storing this Y and Z, now what we need to understand here, what is the value we can provide here? Something like here we are having the references here. Here you can see F I'm trying to store. So simply I'm trying to providing next reference. Okay, next references I given. But as of now, this object, whatever the S object we are having, the particular F object, I'm trying to set as a reference to this particular new node. Okay, so this line is 131 now, it is clear. So we'll move on to the next line here. Now you can see, so first node is replacing here. Because earlier, whatever the first we created, this is also first node here. Okay, now this first node no longer available, but still this F is available. Okay, F is available, but first node is replaced with this node. Now new node, it's become first node also. New become first node here. Okay, first node will contain the previous is null, next is available reference, some y and y and z values here. Okay, first node is completed. F is null. No, this particular F is not a null. We are having some objects here. Whenever we are having some object here, now what we are doing is we are making F dot previous. Okay, whenever we are calling the first node method, the link first or any first node method, it will try to inject the previous information. Now, if we observe what we need to understand here, earlier this we are having null. Earlier, because of the first node, we are having the null. But right now, what happening? This next node references now it is matching with this particular previous. So line number the 136 F. This is only the F. F dot previous. So this section we'll call it as a previous, and this section we'll call it as a next. Right. The previous, what is the node we are trying to inserting? Whatever the newly created node, this is the newly created node we are having. This node, it is going to store into as a previous here, as a previous. Now, observe here. The locations are now changed here. Getting the pen. Now, the locations are changed. So this particular node is stored in the zero index location, and this particular node is stored in the first index location. Earlier, it was in the zero index location. Now it is replaced with the first. Getting the point? Now it is replaced with the first. But how it is replaced? Only, so it's trying to make the new node reference or previous or next to object references. Only in the linked list, we are going to remove the references or we are going to add the references. So this is only the way of making the linked list here. How we are going to make the linking to the each other nodes here. Okay, because of this, now yz as a coming as a first node, and AB now it is moved to the second node here. Now you can see size is increasing, mod count is increasing. So we are coming out of this particular loop here. Okay, now I'm going to remove this particular to string also. Okay, this is the way of writing the add first method internally, because whatever the first value we given, now it is inserting as a first node. We'll go back to the same, and if I'm going to add last node, so how we can add last node? And if I'm going to set as a W and X, I'm trying to providing a, but what is the, as of now, what is the last node? CD. Okay, CD is the last node because the CD cannot contain the next node. Next node is null. Okay, whenever the next node is null, we can treat as a that is the last node. So observe carefully whenever we are trying to call the last node, how it is implementing. So we'll create a one node. Simply I'm explaining here. So the same code is implemented internally. Okay, so this particular value will contain the WX, and here we are going to make as a null because it is a last node. And finally, what we will do, whatever the CD we created, and here I'm going to providing previous node. Okay, so this is the particular CD node. Now what happens internally, this node is going to match with this here. So here we are going to have some references here. Now whenever we are making these references, what we can understand, so WX is a last node. WX is a last node. So if it is a secondary record, now it is replaced with the second as it is. Now this will move on to the third, but only the changes here, the last node cannot contain the this next references. But as of now, we are making the CD as a next references here. Whatever the CD we created, the CD here we are making this particular references here. Okay, this is the only the simple changes is happen inside the last whatever the last method we are going to call here. So observe carefully. This is the add last method I'm calling here. Now I'm going to run in the debug mode. Observe carefully. So this is the add first we called just now. Add last I'm calling. Now internally link last method we are calling here. Okay, link last method we are calling, and this link last so far we call from the add method also. Now you can see. Now you observe carefully. It's a simple logic. First we are loading the last record. The last record basically is a CD record. Okay. Now here you can see CD. Okay, here you can see CD. So far this node next is null, but right now it is going to replace like the next node. We are going to add the references using this line number 151. Observe carefully. New node we created. The new node we are making as a last node. L is not null, and we are adding the next node. So you can see the item, whatever the item we inserted CD, it is having previous node as well as next node. And whatever this particular new node we created, it will have only previous. It will have only previous. The next node is null. So that whenever the next node is null, the node will treat it as a last node. Okay, size plus and mod count. So right now, what is the size we are having? Something like 4. 4 records we inserted inside this particular linked list. Now you can see. So CD is a third position, WX is in the fourth position. Okay, so this is basically, if we observe, these objects are not going to store in the this manner. This objects not going to store like this position, like 0, 1, 2, 3, 4. Getting the point. If it is stored like this, we need to do some shift operations here. Getting the point. But here, it is not storing here. If we observe carefully, so before going to discuss about this particular one, how it is implemented, earlier, first I will show you. So before calling this particular add first, internally, what happens this? Now here, how many nodes we created earlier? So only one node. Something like AB we created. The previous we made as a null. AB I'm providing, and the AB containing the next node. So far, this is the first record. Because of this, what happens internally? Because of this, there is no next references also. Getting the point. Next references also. First record I'm talking about here. The first record will contain like this. Previous will null and next will also null. Only value will store. Whenever I'm trying to inserting this particular CD, internally what we are doing is we are trying to creating one more node. And whenever I'm trying to load, so this node, it will act as a first as well as and last also. First and last, whatever the node we created, first one, and after creating the second node, this node will act only first. Okay, last node this. Okay, whenever it is a last node is, now what happens internally? We are making this particular node as a null, and here we are going to have the references. So this is the references will contain this. So this is the previous node will contain, and here this is the next node will contain. Next node contain. Okay, now the CD is created. CD is created. But whenever I'm trying to create a one more record, something like Y and Z, I'm not disturbing this node and I'm not disturbing this particular node. So I'm trying to add references here. Only the previous node, as of now, we don't have any references. I'm going to provide the references. That's it. I'm not doing any other changes. So how I'm trying to providing the changes here? So this is important. Here I'm trying to creating, this is the node. Okay. This is the node I'm trying to create. And here the previous node is every time it is null, and the next references will move on to the previous reference. Getting the point? Only references we are going to change here. The position basically how it is changing here internally, based on the iterations here, it will try to look up the what all the next nodes are having. Based on that, it will try to load the objects here. Getting the point? So here, just we replace the previous node is null. Now it is identify the this object here. Now it is replaced with this particular object here. Even though, even though this particular position 1 we are calling, even though we are trying to providing this particular 1, if we observe internally, we are checking the position, but we are calling the link last only. Okay, link last only we are calling. This is important here. Now, because of this particular link last here, whatever the new record we are going to create, every time the new node is going to created in the last node only. So is it clear? Okay. So if it is clear, now, so far how many records we inserted? These are all the 4 records. What we need to understand here, the add methods are we discuss here. We'll go to the file, anything we are missing. Inside this particular file, we'll see. So this add method we already identified. Sorted set. And queue. Okay, so add method, this is the same one. So offer method. We'll discuss about the offer method, how it is going to work. Because offer is coming from the queue. This offer method we need to understand. Here I'm going to write the offer method. Okay. Offer method we are having, offer first method we are having, offer last method also we are having. But this offer is coming from the queue, and the remaining 2 methods are coming from the DQ interface. So if I'm going to add this, what is the value we can add? Something like EF. Okay, so simply I'm trying to write this EF value. Now we'll debug code. So how this particular code is going to work internally because of this particular offer method. Now you can see add first, add last I'm calling, and offer method I'm calling. Now internally, what is the method we are calling? So internally, what is the method we are calling? Basically, add method we are calling. Okay, so now observe carefully anything. Now you can see adds the specified element at the last element. Getting the point? So whatever the element we are adding with help of this particular offer method, every time it will try to add in the last node here. Because whenever we are calling this particular add also internally, it will try to set as a last node only. Now if I'm going to show you this particular add method internally, so we are calling link last here. So now after xy, this ef is going to store. After xy, this ef is going to store. So what is the last node right now we are having? Something like wx. Wx is our last node. Now, after this, now I'm trying to create the node with help of this particular previous references. The next references I'm making the null. So same thing, this method again we are discussing here. This particular logic we executed multiple times here. Okay, L is not a null, and next references we are making, whatever the new node we created. What is the new node? EF. EF is a last node because next there is no next references here. There is no next references. So now you can see whenever I'm trying to run EF. Okay, EF is the last element. Now what you understand here, whenever we are calling this particular offer method, it will try to work as the same add method. It will try to work as a same add method. Now what we need to understand here. So what is the differences between offer method as well as add method? Getting the point. Add method basically it will try to add an element. So if I'm going to add same as a AB. Okay, duplicate elements are allowed or not. So this particular duplicate elements are, we'll see how it is going to insert here. So here we are having AB and here also we are trying to inserting AB. Getting the point here. So happily we can insert the duplicate nodes also, something like duplicate record. But the differences is important. As of now, what is the differences we are having now? So to understand this, first what we need to move on to the collection interface as well as the particular queue interface, so that what is the information they provided, we need to understand the add method as well as the offer method. Most of the cases, getting the point, most of the cases the add and offer method will do the same. Okay, now I will go to this particular collection first. Control Shift T. Collection, and here I'm going to add method. Now you can see what we need to understand here. So now you can see ensure that this particular collection can contain the specified element. So whatever the parameter we are going to pass, now what happens internally, it will try to return true. Okay, when if this particular collection changed here, like if the collection is modified or if the collection is inserted the value, it will try to return as a true value. But now what happening here, if this particular collection does not permit the duplicate, if this particular collection does not permit the duplicates, so what happens internally, it will return false here. So this section we'll need to understand here. So instead of offer, because already we identified, I'm going to call add method. I'm calling add method. Now we'll see what happening internally. So this particular linked list, it is not working here, because if it is a duplicate value, it should return false here. But internally, it is not returning anything. Now you can see simply we are calling linked list every time we are trying to returning as a true. Every time we are trying to providing as a this particular true value. So we'll see this add method for this particular list interface it will work differently, and for the set interface it will try to work with differently. Okay, this is important here, but only what we can understand in the linked list, whenever we are trying to add method and offer method, it will try to insert the record at the last of this particular node here. Okay, this is we need to understand. And another important section, offer first. If I'm going to provide offer first, what happens internally? This is we need to understand here. Now simply I'm calling this offer first. Now which method it is calling internally? Add first method it is calling. Okay. So it will, now you can see at the front of this particular list. So it is trying to call the add first method. If I'm going to show you this link first method. Okay. Finally, it is trying to call on the same method. Now here, whatever we discuss here, it's like add first we called here. The add first internally it is called the link first. So offer first also it is calling internally same. Getting the point. So it is working on the same. But this example where we can understand very closely in the DQ interfaces. So DQ will give you the more information about the offer first as well as the offer last related sections here. Okay. Now, if I'm not adding this, so directly, if I'm going to add this particular offer first, what happens internally? Only one record. Getting the point. Only one record we are trying to store. Okay, so don't worry as of now. We'll discuss more about this particular DQ related section in the implementation of the DQ related, because most of the methods are performing same, but only the DQ will provide the first in first out and first in last out also. So this is the because of this where they implemented the particular DQ interfaces. Okay, so these are all the some inserted related method here. Now we'll move on to the loading related methods here. What are the loading related method we are having? So first we'll discuss about the inside the collection we don't have any load related method like get related method, and whatever the method we are having. So here I'm going to call this get index. Okay, how we can call this particular get index? So here I'm going to call the get index here something like L dot get here. So get first, get last here, and as well as get we can provide. So if I'm going to call this particular get first here, what happened internally? Whatever the first record we are going to have, the first record it will try to load here. Okay, it will try to load this particular first record. The first one is AB. First one is AB. Because of this particular offer first, we are trying to store AB as a first record. Now we'll see how it is implemented, this particular get to first here. Now here directly we are loading the first here. Directly we are loading this particular first node. And if F is null, we are trying to throw the no such element exception. Okay. And otherwise, just we are trying to returning F dot item. F dot item. So it is simple. Directly we are moving onto the node and we are loading the first record. Now, whenever I'm trying to discussing about this one, this is important here, and I will remove this. This is the important here. Now, I'm going to provide as a second. Okay, whenever I'm trying to providing this particular second, this is important here, how it is trying to work internally. Now, observe carefully, I'm calling this, so we are trying to check this particular element here. Now you can see node method I'm calling. So by specifying this particular index here, I'm calling the one node method. Now observe carefully. What happened internally? They're trying to check this particular here first node based on this particular condition. Every time I'm trying to replace him with this particular next node. Okay. And if this particular condition is not satisfied, I'm trying to move on to the else. And here we are trying to load the previous one. Here I'm trying to load the next one. Okay, so finally we are trying to return the whatever the node is going to match here. So the node we are trying to return. After satisfying this particular node internally, we are calling item. Here we are calling item. So that the item value it is going to remove. So here I'm putting the breakpoint. I'm trying to run this example in the debug mode. Now you can see. So what is the index I'm providing? 2. Okay, whenever I'm trying to providing this particular second index, first we need to understand. So index less than 2, this particular size here. So we need to understand here, it is not matched the if condition. So it is trying to move on to the else section. So last node. What is the last node we are having? Something like WX. Okay, WX is our last node. So using this particular last node, now what I'm doing is, every time I'm calling x dot previous. X dot previous. X dot previous is nothing but it will give you the previous node. Okay, it will give you the previous node. Now you can see, so size -1. What is the size right now? 5. We are trying to store as a -1, like I value is a 4, and I value we are making index here, and I minus minus. So now you can see we are repeating this particular loop as a reverse order. Getting the point? We are trying to repeat this particular loop as a reverse here. So finally, whenever the condition is satisfied, I'm trying to load the previous node. So what is the previous node we are having? Now if I want to understand the previous node, here we can go for the previous node. So what is the previous node? CD. Okay. What is the previous node? How many times this particular loop will repeat? Only 2 times. 4 and third. 4 and third. Because in the second here we made as a greater than. Okay, if it is the greater than or equals to, this particular loop will repeat third iterations, but only 2 times will repeat, like 2 times will repeat here. And what is the second record we are going to have? the second index record is going to return here. Now observe carefully. So this is the second one, the previous one. Now the condition will satisfy or not. So now this condition will not satisfy. Directly it will move on to the return X here. So what is the X it is having? What is the X it is having? This is the one. So item is AB and it is containing the next and the previous one. Okay. So now what you understand here, whenever I'm trying to providing this particular index here, so what is the item we are loading? Something like AB. So we are trying to load as a AB here. Okay. This is important we need to understand here. This is important we need to understand here. Whenever I'm trying to providing this particular index here, so now what happening internally? So either it will try to move on to the next or it will try to remove on the previous information. So based on that, it is trying to load the appropriate node record here. So you can see 0, 1 and 2. Okay, whatever the AB we provided, it is trying to load this. So if I'm going to give this one as a something like a EF, so that we can easily understand how this particular example is now printing. So finally, the same AB is printing and which is available in the third index location. So this is all about the loading the specified index, like based on this particular, like loading the specified node object here based on the index value here. Okay, and internally we are trying to checking again the index here, whether the given index is available within the range or not. So this is we are checking here. This is one of the important example we need to understand. Okay, this is one of the important example we need to understand. And any other methods, I will remove the unwanted stuff. Okay, now we identify the get. Now we need to identify the set here. So how we can identify this particular set here? So ll dot set method, and here what is the index we can provide? Something like I'm going to give as a 2. Okay, the 2 only I'm going to modify with help of this particular okay set. With help of this particular set, I'm going to call this particular information. Okay, now what we need to understand here, getting the pen, what we need to understand how this particular set method it is going to work internally. First we are checking whether this particular, getting the point, whether this particular index is available within the range or not. Okay, whatever the index we are having, the range within the size only. Okay, because we given as a 2. So now what you need to understand, based on this particular index I'm trying to load. Just now we discussed about the get method. The get method also internally it is trying to load based on the index. We are trying to load the specified node object. Same thing we are implementing here. Okay, same thing here we are implementing this. Now what you can understand, x dot item. Once a node is loaded, we are trying to load the item value. Okay, we are trying to load the item value. Now once we load, this is the old value, and using this simply we are calling the element, whatever the element we are having. So something like whatever the new value we are having, I'm trying to set as a item. Now you can see it is very simple here. Once a node is identified, the element value we are trying to set into the item. Okay, the old value now it is replaced with this particular original value. Now it is replaced with this particular item. So now you can see compared to this particular array list also what we are doing basically. So based on the index here, we'll try to match the appropriate index and we'll load the object here. And once object is loaded, the value will replace with the new value. Okay, same way what we are doing is, so first we are checking the index is available within the range or not, and if it is available, based on the index we are loading the node object here. Once a node object we are loading, so with help of this particular x dot item, we are replacing the old value with the new value. Okay, so this is the simple logic is implemented inside this particular set. Now what we can do, how this particular set value is going to modify. Now you can see, so earlier it is a AB, now it is replaced with this particular set, and using this particular get to, now we are trying to load only the whatever the newly setted value. Okay, so any questions? Any questions on this particular set method? Okay, so if we don't have anything, now we'll identify the any other method we are having. Any other method we are having here. Now what you need to understand here, so add all method. So we can discuss about the add all method, how it is going to work here. So right now after set, if I want to create a add all, now what I will do, for this add all, I am going to create a one array list here, because the parameter is passing as a collection here. We can provide any add all information. Now I will make as a integer. So AL I'm making, and I will try to call the same add method, and okay, 3 records, and same way 4 records I am inserting. Okay, after inserting this particular 4 records, and here I'm going to call ll dot add all method, and here I'm going to call pass the collection. So this is important. Can I pause this particular AL here? Now we'll get an error. Okay, why we are getting an error? Any idea? So the why I'm getting the line number 21. So try to think and let me know. So why we are getting this error? This is important here.
String and integer, sir.
Exactly. So here the add all method internally, it is expecting the generic type. We have a one condition. So because of that, it is trying to giving me an error. Now what we need to understand here. So this is the specified condition we need to add. So the integer will not work here. Whatever we are giving, we need to give as a string only. Okay, I will try to replace with this particular string, and I will modify this particular value as a string only. Okay, so this is all about the one of the important example, and where we implemented this. Now if I'm going to open, this is the section. This particular section, now it is given an error here. So what is the e? Basically we provided something like a string, and whatever we are providing this as a integer. This particular integer is not going to extend internally string class. Getting the point? Because of this only we are getting an error. Okay, now what we are calling internally, add all method we are calling. Now you can see whenever I'm calling the add all, so what is the size they are providing here? So after the from the size, what is the as of now size? I hope 5 or 6. I hope so. The size is going to add here, and if it is a 5, index is a 5, and again we are converting to object array. Whatever we are passing this particular value, we are converting as an object array. Now trying to load the length here. So here we are having previous and successor nodes here. Now you can see using this particular condition. So this is having some bigger value. So like a bigger code they implemented. We'll try to identify how it is implementing internally. Now I'm going to run as a debug mode so that we can easily understand how this particular add all is going to work internally. Okay, set method, add all method I'm calling it. Now I'm trying to move inside this add all method. One more add all method is calling, checking the position. So position, because we are not giving the index value. By default, linked list only is providing the position. So we don't need to check because it is satisfy the condition. So now we converted object array. So whenever we converted here, what all the values we are having? Now you can see 0 to 3. So around 4 records we are having. So these are all the values. The left side they are providing as the indexes. The right side we are having original values. Now what is the length? The length we are going to get as a 4. Length we are getting as a 4. So condition is the below condition is failed. Now we are moving into the index equals to size. So what is the index right now? 5, and the size also same. Getting the point? Size and index both are same. When both are same, now what I am doing is the successor we are making as a null, and the previous one we are making as a last node. Getting the point? Just here line number 417 I declared the two nodes here. Getting the point? And here I'm trying to initializing the value. Okay, the previous nodes I'm trying to initializing with the last, and the current one I'm trying to initializing with the null. Okay, now you can see after this, so we are moving into the object iteration. Okay, this is important. We are trying to work on the object iteration here, and whatever the character like object array we are having, now I'm trying to repeating this with help of this particular for each iterator. So this is not the for loop. We are trying to use the for each here. Okay, now what we are doing internally, we are trying to load the whatever the object we are having. Now I'm trying to converting into this particular E because it is a element data only. Now you can see once I converted E, what is the value we are having? So 12. 12 we are having. Okay. Now what I'm doing is I'm trying to creating the new node. Getting the point? Every time I'm creating a node here. So how many times this particular loop will repeat? Getting the point? How many times this particular loop is going to repeat? So same count of nodes are going to created internally, and every time I'm making the previous node. So what is the previous node? Here we provide as a the last node. Right now we are making as a previous one. And now what you understand here? Every time we are going to create, those are all the last nodes only. Whenever we are trying to create an object with help of the add all the nodes are going to create it internally at the last nodes only. There is no between nodes and there is no first nodes. Every time it will try to create as a last node. Okay, so this section is indicating last node. Every time it will contain the null value. Now you can see previous is null. No, so previous is not a null. So previous dot next. Right now, whatever the next node we are having, the next node, now it is replacing with this particular new node, whatever the new node we created now. Okay, what is the value we are having? 12. Okay, so what is the previous node we are having earlier? Something like WX. Yeah, so WX is the previous node. Now the next node is null. Now it is going to like have the value with help of this particular line number 432. Now you can see, so after this, if I'm going to show you the previous one, now you can see next node is replaced here. Previous node is replaced here. So WX is not a last node. WX is a last node here. So which is the last node now? I'm initializing here this one only. Whatever the newly created node, this is the last node. Okay, observe. So here I'm trying to overriding whatever the previous node we are having. The previous node, now it is replaced with this particular new node here. After this, now what I'm doing is, again I'm creating the new node. I'm previous dot next. So previously, this is the node we created with help of this 12. Okay, with help of this particular 12, we created. Now, where is that? Here you can see, here 12 is available. Now, so the next node is implemented. Previous node and next node. And what is the new node we are having? Where is the new node? Here. Okay, the new node, every next is null, and previous we are having. So that the new node, whatever the new node we created, this is the last node. Right now, this is the last node. So because of this particular loop, 4 times it is going to create here. Okay. So this is important here. 4 times it is creating internally. Now it is coming. So and whatever the last node, this is the last node here. Now you can see 96 we are having. Next node is null. Okay, 96 is the last node. After this, now success is null as of now. This particular success, we don't have any information. When we are having this, we are trying to store as a whatever the previous node we created, now we are making as a last one. Okay, so size. What is the new number we are having? 4. And what is the size earlier? Something like 5, I hope. 5. Okay, 5 plus 4, 9. So the size, it will become 9. Size will become 9 here. Now you can see this is a 9 it is returning here. Where is the size? Okay, inside this we can identify. This is not showing the size. Okay, anyway, now you can see the size we are able to see here, 9 value. What happens? Now you can see size is 9 and mod count we cannot check this because internal purpose they implemented. Now returning true. So once we are calling this, now what do we understand here? Every time with help of this particular add all method, every time we are trying to store the data at the end of the given linked list here. Getting the point? Now if I'm going to print this, so 12, 45, 78, 96, it is added at the end of the particular linked list here. Okay, so this is all about the add all method, and the same way internally you can come up with the add all which is expecting index here, Getting the point? This is important here. So we discussed the two method inside this particular add all. Two methods are same here. If you call this particular add all, or if you are trying to call with add all with something like 4, if you specify 4 comma al, now what happens internally? So it will start with here. It will start with before this particular double x here, and it will insert this particular value. Last it will end up with double x here. Now you can see. So what happens internally? So anything? 4 should be 0, 1, 2, 3, 4. Yeah, it should be replace this basically. Now let's see. Here I'm trying to providing index here. Now where I'm checking, index is not a size. So this section is not matching. So when this section not matching, we are loading. So this is the fourth record, something like a double x. Whatever this particular double x we are having, this will load. Okay, so whenever it is loading, now understand. Now if you observe carefully, so else section is loading. Okay, and this particular previous whatever we are having, now we are trying to set into this particular previous. So something like a CD. The CD, it's trying to set as the previous record here. After this, we are repeating this particular loop here. Now, what is the previous? We are going to make as a CD. Correct only it is implemented, but why we are getting? So previous dot next, new node is replacing, and previous is reflecting. Correct only. Anything we are missing? Successor null not. Previous node, what we are going to get? Whatever we added, this next, it's end up with a successor. And what we are having? Correct only. Okay, something, I don't know why. Sorry, I did not save, I hope. Yeah. Let me run this. Now you can see whatever we are expecting, same. Now you can see in the fourth index location only, the values are creating, the last it is. Getting the point? So earlier example, I did not save after modifying this. Because of that, we did not get the expected result here. Getting the point? This is important. If I give the 5, 5 is a last here. Okay, 4 is the middle character, because you can see like 1 0 index 1 and second and third and fourth here. Getting the pen? 0 to 4, the size we are having 5. Getting the pen? So because of this, now what happens internally? Whatever we insert in the fourth index location, we are loading the fourth node. After loading the fourth node, we are trying to replacing the value. So the values are replaced here in the fourth, and now finally the double X is move on to the last one. Okay, so this is another important example we are having regarding this particular linked list. So far we discussed about the idle with the indexes also. Whenever we are giving the index information, now it will load the node object. Once it is noded, it will try to make the previous node as well as the next node references here. So it is simple. So by understanding, by seeing this particular example, it is simple. But I'm requesting everyone practice with multiple objects here. So try with the integer, try with the string, come up with whatever the wrapper classes we are having. Try to implement all the example. You will understand how it is implementing array list and linked list here. Okay. So any questions or regarding our today's session, what we discuss here? Okay. So if we don't have anything, now we'll continue on the Monday, whatever we are having the continuation. So we discuss about the add method, add all, so offer method, and we have some different method we are having, like a remove method, retain all method, how the remove will work internally in the linked list. Okay. And finally, so what are the method we are having? Clear method. So after a clear, we can discuss about the iterator related sections, how it is going to work internally inside this particular linked list. Okay, these are all the so some methods are pending. We'll continue on this particular method on Monday class here. Okay, if we don't have anything, I'm going to stop the session up to here. We'll see you on Monday.
Thank you, sir.
Thank you, sir.
Thank you.